Hello class, and welcome to today's algebra lesson, which is about division properties of exponents. By the end of today's lesson, you will be able to use division properties to simplify expressions with exponents. So we're going to continue on with our rules for simplifying. We still want to cover having each variable appear exactly once and no double exponents, so no powers of powers. And now we're going to get into the fact that all fractions also must be simplified. So we're going to start with the quotient of powers rule, and this is saying that two powers being divided that have the same base, we're now going to subtract their exponents. So the reason we are able to do this is because if we have our top, which is 9 b's being multiplied, 1, 2, 3, 4, 5, 6, 7, 8, 9 b's being multiplied, and we divide it, in this case, by 5 b's being multiplied together. Every time you divide a number by itself, it's just going to turn into 1 or it's going to cancel out. So these first 5 pairs cancel each other out, leaving us with just 4 b's being multiplied, or taking that shortcut, which is what our rule tells us to do, and subtracting our exponents. So 9 minus 5 is what gives us b to the 4th power. Looking at that from a more complex situation, first we're going to look at our coefficients. In this case, 8 can actually be divided by 2, and that's going to turn into 4. If it had been the other way around, with the smaller value in the numerator, you would just treat that as a reduced fraction. So in this case, the numerator was greater, so I can divide it out. If it was a numerator smaller or a fraction that you couldn't completely reduce, so let's say that it was going to be 9 over 6, both of those could be divided by 3, so putting it as 3 halves. So when you're looking at the coefficients, it's normal rules of reducing fractions. Either divide when you can, and if you can't, make sure it is simplified as much as possible. Then we look at each of our values, so k to the 7th divided by k to the 5th, subtracting those two exponents gives me k to the 2nd. M to the 10th minus m to the 3rd gives me m to the 7th when I divide, and then p divided by p, those cancel out, so there is no p in my final results. Go ahead and try this one on your own. Doing your division, you get 8, and then simplifying the exponents, it's d to the 2nd and c to the 4th. The next rule is going to be the power of a quotient. So to find the power of a quotient, distribute the power to all possible values in the numerator and the denominator. So this is, again, our distributive property rule for exponents. This exponent now just needs to go to all pieces. So in this case, I would distribute it up to the 3. So I would have 3 to the 5th times 3 to the 5th, which is essentially 3 squared over 5 squared. So we can skip writing this part out and just distribute that square. Because it is all numerical values, I can solve 3 squared, which is 9, and 5 squared, which is 25, giving me a fraction of 9/25 when I simplify this expression. If it is a more complex problem, once again, you want to distribute that exponent into everything. So in the numerator, it's the 2, the p to the 5th, and the m to the 12th. So I've got 2 to the 5th, following our rules from yesterday. If I've got a power and a power, I am multiplying those values. So that's p to the 25th, and then m to the 60th. It also needs to be distributed to the denominator. So we've got 3m and n down here. So I've got 3 to the 5th, m to the 8 times 5, because it's a power of a power, which is m to the 40th, and then n to the 5th, because it used to be n to the 1st. Now when I simplify this, I've got 2 to the 5th power, which is going to give me 32. I've got p to the 25th, m to the 60th, and then on the denominator, I've got 3 to the 5th, which is 200 and 43, m to the 40th, and n to the 5th. Now, remember, one of our rules is that every variable can only show up once. So because m shows up twice, I have to use my quotient of power rules. 60 minus 40 is going to give you 20. So your final answer for this one is going to be 32p to the 25th, m to the 20th, after I do my subtracting of these two exponents here, and then over 243 n to the 5th. There was nothing for the p and the n to be combined with, so those stay put as you are simplifying. Go ahead and try this one on your own. So distributing that squared into each value, 2 to the 2nd, y to the 4th, 3 squared, x to the 6th, giving you the final answer of 4y to the 4th over 9x to the 6th. So now we're going to talk about what happens when we have an exponent of 0. We're going to use a couple numerical examples to illustrate this reasoning. So I've got 4 to the 3rd, which is 4 times 4 times 4, which is 64. 4 to the 2nd, which is just 4 times 4, giving you 16. Notice, to get from 4 to the 3rd to 4 to the 2nd, I divided by 4. I took away a multiplying by 4, aka I divided by 4. Our answer also was divided by 4. When I have 4 to the 1st, that's just 4. So once again, I'm getting rid of a multiplication by dividing. To get to 4 to the 0 power, we would follow our same pattern and divide by 4, giving us an answer of 1. If I come over here and look at what happens when I have 13, 13 to the 3rd power is 13 times 13 times 13, which is going to give you an answer of 2,197. If I do 13 to the 2nd, it's just 13 times 13, which is 169. So to get from 13 to the 3rd to 13 to the 2nd, once again, you divided by a 13. You canceled that out. When I go down to 13 to the 1st, it's just 13. How did I get rid of that multiplication? I did division by dividing by the base. So to get to 13 to the 0 power, we would follow our same pattern, dividing by 13, which is going to give you an answer of 1. So notice, anytime we have a non-zero base raised to a 0 power, the answer is always 1. If no matter what, the answer is always going to be 1, because you're going to be dividing the base by itself. So if I have 2/7 to the 0 power, the answer is 1. If I have 14a to the 4th, b to the 15th, c to the 8th to the 0 power, the answer is 1. Go ahead and try this one on your own. Because it's to the 0 power, the answer is 1. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.